Hello, I'm Joyce Woodworth. Welcome to the Spirit of the Heartland. The composite industry is strong and thriving in Winona, Minnesota. Not only are there several local manufacturing companies producing composite materials for the transportation and aerospace fields, medical and recreational purposes, but our local Winona State University provides the only undergraduate degree in composite engineering in the nation. Today we're going to find out about composites, learn more about the engineering program here at WSU, and visit with some of the local leaders in the composite industry. When Jenny and Joseph Miller first came to America from the old country, little did they know that by choosing Winona, Minnesota as their home, they were paving the way for this beautiful Midwest town to be one of the giants in composite engineering for the nation. Jenny and Joseph had 8 children, all born in Winona. Rudy in 1903, and the youngest, Ben, was born in 1910. Joseph began trading rags and scrap iron for a living, and in 1923, he and his son Rudy started Miller Waste Mills, which is still in business today. It was not long when Ben joined the business, and the 2 entrepreneurial brothers began several offshoot businesses, dealing with the lubrication of railroad car axles. Hugh Miller, Ben's son and CEO of RTP, explains the transition from the raw materials used in the first Miller business to the modern composite materials the Miller brothers brought to Winona in 1947.
That essentially is reprocessing fabric, mostly cotton, some wool, and some other organic fibers. Biggest use by far was for use in railroads. You dip some of this stuff in oil and put it in what's called the journal box. It would keep the wheels lubricated. They started that business in 23, and it was quite successful. And what happened, for reasons, again, I cannot explain, they realized that after World War II, that whole thing was going to fade out because ball bearings came in and that would no longer be necessary. My father, I must say mainly, and my uncle decided they had to do something different, so they looked around and found a unusual plastic business which was available. I think it was either owned by Drac or Union Carbide, and they brought that back. They didn't want to get out of it. That was the start of Fiberite, to say. From that, I would say rather humble beginning in 47, 48, whatever it was, when Fiberite was started. They eventually got involved in aerospace programs, which was the modern day composite type program. That, I think, is where we're probably heading here.
The composite materials the Miller brothers started with at Fiberite in 1947 did lead to products developed for use in the space-age world. However, they started with materials used in much simpler products, seen in this cafeteria tray used in military mess halls. I'm presently now sitting in Farboris Parzi's office, and Farboris is a professor here in the Composite Materials Engineering School, and he actually dug in the archives for us and found something that's probably the granddaddy of composites here for Winona. Can you sort of describe what we have here, Farboris?
Sure. I got my hands on this somehow, and I've been told that these are probably one of the first composite parts that have been manufactured in this area. And as far as I can tell, the Miller brothers came up with this smart idea that if we add up rags into pieces and be able to incorporate them into plastics, and we will be able to save some money. And at that time, the price of plastics were expensive. We're talking about probably about at least 50, 60 years ago. And they did that, and as a side benefit of that thinking, they made a product that I'm guessing has better impact properties, pure plastic itself.
No, neither one of them had any technical education whatsoever other than high school. But yes, they were very, very gifted at finding good people and bringing them in. So that's how they built the company, bringing good people. And I think that's the key to any business, but they had that gift, yes.
Among the many composite technicians Ben and Rudy brought to Winona was World War II veteran Stan Prosen, a genius in the composite world, who was responsible for making the first part from a carbon fiber material.
I was at the Naval Ordnance Lab, and Ben and Rudy Miller came to see me one day. and they kept coming to see me for about a year. Ben Miller, John David, then Ben would come back, and then Rudy would come back. So they finally hired me in about a year.
Explain to us what carbon fiber is.
Carbon fiber is the strongest fiber there is in the world. Stronger than steel, but it's 6 times lighter weight. Comparing it to an aluminum one, it's 1/3 the weight and many, many times stronger and much stiffer. They're transparent to X-rays. They're used in aircraft, in space a lot. I came to Fiberite. They wanted me to put them in that area of business. Fiberite became the biggest supplier of that material in the whole United States.
Stan Prosen came to Fiberite in 1968, stayed with them for 7 years, and then began his own offshoot composite companies, obtaining 24 patents in composite materials. After his retirement, he decided he couldn't give up creating new products and started all over again, making violin and cello bows.
I always had this feeling that music and carbon fibers and composites go together.
In 1993, he and Jeff Van Fossen began Coda Composites, located at 876 East 4th Street.
The part that we make is the shaft. The shaft is made very similar to how the fishing rod people make their fishing rods, and the golf shaft people make their golf shafts. They're all carbon fiber. This is called the tip, and this is called the frog on this end. We buy the frog from Germany. We buy the horsehair from Asia. They're made to the form you want them, and they're bent so they get right camber, as we say, heated and cured, and then they're sculptured. Sometimes they refer to me as the grandfather of composites.
How do you like that?
If they take the grandfather out of it and say just father, that'd be fine. Carbon fiber part of the business started in 1962, and I was in on the beginning of it, and now I'm still in it. And carbon fibers are so exciting, and even now, if I were younger, I'd start another business.
Fiberite was the nucleus of the composite industry in Winona. Its founders, the Miller brothers, were the instigators. They brought the composite engineers to the city, and consequently spin-off composite companies grew here. They also had a hand in starting the School of Engineering at Winona State University, located in Stark Hall, which is named for Tom Stark, the president of WSU in the 1980s. Up until that time, WSU did not have an engineering degree. Keith Dennehy, professor at the school, tells us how Tom Stark, too, was instrumental in starting the composite engineering program.
So what happened was, as far as our program getting started, back in the late 80s, where the president of Winona State at the time, President Stark, went out and solicited these companies that were involved in composites to find out where the university, what kind of services they could provide to help that industry grow here in Winona. And as a result of that, we started a group called ComTech, Composite Materials Technology Center, that actually provided some testing services for these companies. And they did that through the physics department at the time. My understanding is the governor at the time, Governor Perpich, came through and saw that activity. He made the suggestion that perhaps you want to start an engineering program that has to do with composite materials. The dean at the time, Dean Nielsen, he went out and kind of did a more comprehensive study as to the needs of the composites industry for students that would have an undergraduate engineering degree in composite materials engineering. And the response he got showed that there was definitely a need within the industry. There was a 1 to 2 year process of trying to convince the legislature that there was a need for a composite materials engineering program here at Winona State. Mm-hmm. First classes were held in 1989 for the junior level students. Most of those students had transferred from other related majors in the sciences. And then in 1990, we offered our senior level classes, and our first class graduated that spring. During that time, the building was designed that you're in right now, Stark Hall. Construction started, I believe it was the summer of 1990, and then 2 years later, the building was completed and we moved in here. One of the very nice features of the building was that we knew the program was going to come into the building. So a lot of the labs that you see in here have been specifically designed with the composites program in mind, which has been a real big benefit to the program.
Let's talk about how many students you've had graduated from this program and
Okay.
a little bit more about the program itself.
Okay. Well, since that time, since that first graduating class, we have probably graduated around 250 total students. Right now we have, within the 4 years, freshman through senior year, we have about 125 students. And we'll typically graduate anywhere from 15 to 20, sometimes a little over 20 students per year.
Let's talk about the classes
Sure.
that you offer.
Well, we try and give a well-rounded background to the students. We know that when they get out to industry, they could be involved in either manufacturing, they could be involved in design. They may be involved in doing some research on the actual raw materials themselves. So they all get a strong foundation in chemistry and some of the other pre-engineering areas like math and physics and so forth. The junior year is very similar to a curriculum that you find in other engineering programs. And then finally, it's the senior year that we really focus intensively on composite materials. We try to give them exposure to designing with those materials, how to do analysis of parts to see how they're going to perform. We do testing as far as mechanical testing, and we try and characterize them for other properties like how they'll perform in high temperature environments and things like that. So they really get exposed to a lot of the different areas around composite materials.
We came upon Bekri Abdul-Majid, who is working on some type of a project here with the kids in the Composite Engineering School. What are they doing exactly, Bekri? Can you describe it to us?
Sure. These are senior students in the Composite Materials Engineering program. And in the senior year, they take this class. It's called Mechanical Characterization of Composites. And in the class, they test different types of composite materials to find how strong the material is, how stiff the material is, how durable the material will be, how much impact force it can take, and so on. So in this specific test, they are testing carbon epoxy composite to see how strong in tension it is. Students are divided into groups of three students, and each group is responsible of preparing the material, preparing the specimens, instrumenting the samples, and then testing the samples and getting the results. And then the whole class will share the results and get a summary of the properties of the material.
Okay, thank you for sharing that.
Sure.
I'm now standing with Matt Benson, who is the Composite Technology Director here at the school, and he's going to explain to us exactly what a composite is, right?
Yep.
Okay.
All right, Joyce. Today we're going to start with just some very basic composite materials information. We're going to talk about the two basic components that make up a composite. And I have them on the table in front of us here. The first material that you need in forming any composite is some sort of fiber material. So in front I have carbon fiber in various forms of fabric and in tow form, some Kevlar fiber, and then the most common glass fiber, and also in separate forms as well. So the first thing we need is a fiber. Next is what we use to hold the fibers together, and that is a resin material. So I have a couple of different resin materials here. I have a 2-part epoxy resin in front of me here, and then a thermoplastic resin that is in solid form rather than liquid. With those two materials together, there's literally hundreds of different ways to actually form composite materials. I have 2 of them here today, blade for a hockey stick, which is kind of one end, considered a very high-performance composite, ultralight, and made out of carbon fiber. And then armor material, made out of fiberglass and resin. And this actual armor piece has been shot with multiple rounds. And
wow.
As you can see, they don't go through.
Tell me, when would this be used?
This type of armor material is somewhat of a steel replacement, as are a lot of composites. This one can be used on both structures, like inside bunkers, etc., or on vehicles. Rather than steel, it's a lot lighter than the steel armor plates, so they can put more of the material on.
Awesome, and that starts actually from this material right here,
Yep,
which is, this
correct.
is a fiberglass.
Yep, that is fiberglass.
Oh, interesting. And when would you use the Kevlar?
Kevlar is used in only a few specialty areas, and you've heard of it probably in Kevlar vests that the Army uses. And that's actually usually in its fiber form still, just woven together, not a composite. When they use it in composites, it's typically for wear resistance. When something's going to be possibly skidding a lot, they put in aircraft landing gear. If they were to break, the tires were to pop, the Kevlar would be able to ride on the surface.
Okay, and this is just a string also, right?
Yep, exactly.
Ah.
All of them come in just a fiber form, and they're very simplest form.
Okay, and now then when would you use the carbon fiber?
Carbon is used whenever you need something that's extremely stiff and extremely light, like in sporting goods.
Okay.
Sporting goods, a lot of sporting goods use carbon fiber. It is one of the more expensive fibers, but when you need really lightweight and really stiff is when you go with carbon.
Awesome, what a fabulous material. Well, tell me, what goes on in the technology department here?
Okay, the Composite Material Technology Center was founded actually in 1987, before the school started. And it was set up to do testing for the local composites industry that was already here. So the center hires students that are in the program that actually do all the testing. And basically my job then is to find clients for them, so they get to interact with the clients and learn kind of on a first-hand basis and hands-on how to do these types of things.
Okay, now I understand that you have one of those testing set up for us today.
Yes, we do.
And who and what are we testing?
We're testing some bats for Mikan Composites or Mikan Sports in Caledonia, Minnesota.
Okay, well, let's see how that's done.
All right.
This is Mike Karski, who is a senior here this year, and he is in the composite program. And Mike, tell me what the composite program has been like for you.
It's been a lot of math is involved in the composite program. I got involved because I've always enjoyed math, and I didn't know what I wanted to do. A rep came from Winona, introduced me to this, and it sounded really interesting. Composites is huge in the future, and I enjoy aviation, and it's big in the aviation field, so that's what my main interest.
Sounds awesome. Now you're going to be doing a test for us. Do you want to describe the test to us?
Yeah, this is basically an impact test for impact strength. What we have is a dart inside, somewhat like this, but it's round on the end here. You can see it. It's hanging right here by a magnet. Bring it up here about 18 inches. And we know the weight, and with gravity we can find out the impact strength as it comes down. And all we do is turn the magnet off. Are you ready for this?
Sure. Is it loud?
No, it shouldn't.
Okay.
It shouldn't do too much here.
Well, how many pounds of pressure just hit that bat?
That's probably a 10-pound weight there.
Okay.
And we dropped it from 18 inches, so take gravity, and you got your calculation there.
Ah, there's the math.
Yes.
Okay, so how did it stand up?
It passed that test.
All right, so it passed this test, and we're ready to go over and see the stiffness
That's
of it.
right.
All right, let's do that. Karen, would you describe exactly what you're testing here?
Well, what we're doing is we're running a test to determine the residual strength after impact. And so what's going to happen is we're going to be applying a load here, and then it measures displacement of the material, which will then show up on the computer over there. But we are applying a greater load than this bat would ever see, so that we can see at what loading it actually will fail. So, and for this test, you might need safety glasses.
Well, why?
So-
Is it actually going to break, or?
It might crunch and crackle a little bit, and you never know when pieces are going to fly off. So it's just a good idea to be safe. So.
Okay. So now the computer is telling this machine to apply a certain amount of pressure.
Yep.
Right?
You can hear it starting to crack.
Ooh. It's not going to pop in our faces.
Hopefully not. So Joyce, here you can see the data is plotted into a little graph, and you can see here we have the initial failure. That's where the sample started to crack when you heard it first start crackling. And then all the way up here is the maximum load that we were able to apply, and that was a little over 1,100 pounds force. So that's quite a bit of force applied onto the bat.
Okay, so now the next step is you write down the data and send it off to the company?
Yep, we'll actually send this data file to the company, to Mike and Bat, and those engineers will have all of the data that was collected, and then they can take that and use it to design the bats differently or alter the materials or, something like that.
Interesting, Karen. Thank you so much.
Great, thank you.
This is Chris Debo, who's a senior here at the Composite Materials Engineering School. Hi, Chris.
Hi, nice to meet you.
Well, where are you from, Chris?
I'm from the Twin Cities area in Minnesota, actually. Maplewood and North St. Paul is where I went to high school.
Okay, now I understand this is your senior year.
Yep.
And what brought you to Winona?
Just the fact that the composite materials program is very different than any of the other programs that are around right now. And this is actually the only university in the country that offers a 4-year composite materials engineering degree. So that's what attracted me to it.
Well, how has it been for you for 4 years?
It's been hard, but I've learned a lot and I've gained a lot of good experience, not only through classes but through internships as well. There's a lot of good companies in the area that provide opportunities to have internships as well.
With your internship at RTP, tell me what you learned here that's helping you in what you're doing at RTP.
A lot of the different things that I've learned here that have to do with composites and different of the polymers and resins and stuff, I can apply a lot of that information over at RTP for my job. My job over there is I'm helping one of the engineers doing alternate sourcing, and what that is we investigate whether or not we can use different polymers and resins within their materials. So a lot of the different things I've learned in the classroom here have helped me at my job there.
The students that have come out of the Winona State program have been very, very competitive with the other programs. They have hands-on experience with composites, and thus they usually hit the ground running here. They've been able to, again, come up with these formulations that meet our customers' requirements. I mentioned we hired 23 students from the program. Currently, about 11 of the 19 engineers that I have working in product development are from the program.
Now, Keith, the composite industry is very important to Winona, Minnesota.
Right.
There, like you said before, there's a lot of people that started here with fiberite because of composites, and then they went on to make their own industries.
Correct.
Tell me about the industries here in Winona and what they make.
Well, there's kind of a variety. We have companies that really provide raw materials to a subsequent company that will take those raw materials and actually produce a product that you and I might use. And the companies along those lines, obviously probably the largest here in Winona would be RTP company.
RTP, or Reinforced Thermoplastics, located at 58 East Front Street, is a spin-off company of Fiberite, began by Ben Miller. Fiberite itself was sold in 1980 to Beatrice Foods for $60 million. Today it is owned by Cytec Engineered Materials and is located at 501 West 3rd Street. Other companies in Winona providing composite materials are Plasticomp at 4455 Thoyer Boulevard and Ticona Cellstrand at 4610 Thoyer Boulevard.
And then at the other end would be the companies that are actually making finished product here in Winona. And examples of those would be Winona Canoe.
Winona Canoe, located at 1252 Bundy Boulevard, has been making composite canoes since 1970 in Winona, and now its counterpart, Current Designs, located behind Menards at the foot of Sugarloaf, manufactures top-of-the-line composite kayaks. Cotabow in Winona's East End produces a finished composite product. Keith Dennehy tells us about another composite company located at 1700 Wilkie Drive called CPI.
Composite Products, or CPI. They make products like running boards for the Ford pickup truck series. They make some products for John Deere. So in that case, they're actually making a finished product, whereas some of the other companies here in Winona are actually making raw materials that go into those finished products.
Okay. Well, Dr. Keith, very nice to meet you. Thank you so much, and good luck with your program here.
Thank you very much. Thanks for visiting.
I felt it very fitting that we close the show here with President of the University, Dr. Judith Rameli, and she's going to tell us what the future of the Composite School here is for the Winona State University. Hi, Dr. Rameli.
Hello, I'm glad to be here.
Great.
The future of the Composites program is connected deeply into the future of the whole university. In fact, it's one of our signature programs, of which we have several. We have a sense of purpose and a sense of place, and it comes out of the experience of Winona itself. This program has demonstrated the roots of the composites industry in this community, and also the roots of our composite engineering program, which comes right out of the aspirations of this community to build an industry of very special nature because of where we are in our time and place in history. And so the composite engineering program, which sets us apart from other undergraduate experiences, will continue to develop as the industry develops. What I've observed in spending time in some of the companies is that it's not just about engineering. It's about working in a global environment. It's about producing things better than the customers expected, sooner than they thought they would have the solution, and at a price that surprised them in its reasonableness. And so our program will begin to mesh more closely with what we're doing in our College of Business, what we're doing in our communications programs and in our math and science programs, so that the kinds of engineers we turn out are the kinds of people that are needed in this industry, people who know the engineering, but also know people, know systems, know global economies, understand what it takes to please a customer. And so for us, embedding a single engineering program in an entire universe of opportunity, I think we'll be reconsidering what it means to be an engineer in the 21st century.
Sounds like a great plan. Thank you so much.
Thank you.
And thank you for joining me today. We have learned a lot about the university's program here in composite engineering. Not only does it offer great quality education for its students, but it also is very helpful to the composite industry here in our area. Thanks for joining me. Please join me again next week. Till then, enjoy the spirit of the Heartland. This show can be seen Saturday, Sunday, Monday, and Tuesday at 1 and 7 p.m.